right, we have another minute to go, but thanks for coming back. I know it was a short break, but we want to make sure we start on time. And as I said, today we were always on time. There's only 2 gentlemen that completely mess up that statistic.
We will challenge it.
All right, folks, before we get started, who of you is aware of Kubestronauts? Who has ever seen a Kubestronaut in real wildlife? Who has seen 2 Kubestronauts on stage at Cloud Native Days Austria? 2 Kubestronauts today, really awesome. Thank you so much for doing this talk, reverse engineering a Kubernetes platform. And besides being Kubestronauts, I also made some notes because you just told me that I want to make sure I highlight this. Someone of you has a data center at home with 3 terabytes of RAM and 400 terabyte of HDD. Who of you is good?
Yeah, I guess that's me.
It's you, yeah. And I think this will also be part of your story. Yeah?
A little bit, yeah.
A little bit. Cool. Hey, guys, thank you so much for being here in Vienna. The time runs. We have 45 minutes where we try to do it at 40 and then 5 minutes for questions. And everybody in the room, after this, we have the final keynote and then the final closing session where we also announce all of the winners. But now, the floor is yours, guys.
Perfect.
Thank you.
Thank you very much for the warm introduction. We are happy to be here. And before we are starting, first question, how many of you already heard about platform engineering or IDP? A lot. How many of you already built one IDP or platform for your company? How many of you already have built one IDP or a platform that is also getting adopted by the organization, not pushed and forced to use from the developer? Nice one. And the last question is, how many of you already relabeled from whatever you was before to platform engineer? Okay, not few. I guess after our 10th slide, we will change. Maybe we should pivot your role and seeing what platform engineering now looks like in salary. But back to the topic, we will, of course, reverse a platform engineer or already an IDP from UI to GitOps and showing you a new approach. Hopefully a new approach for you to thinking not in layers, but thinking in planes. But we will start it. Andy already gave us a nice introduction, just few things. Max, if you want to add something.
I'm Maximilian Marschall, working at Evola, and I guess most people know me for my home lab, so I included a little slide about my home lab. In numbers, it's quite a big one already, so a full rack, some hosts, a few hundred cores, and some terabytes of memory. And yeah, and then we have Artem on stage with me.
Thank you very much. I have also a home lab, but my home lab looks like a Mac Mini with a Raspberry 4. So compared to you, you have a data center and I have a home lab. And to me, I'm Artem Lajko, working as I relabeled myself before the market hit it. So I was faster than the market to platform engineer, not just to earning more money, but also to afford shoes like this one. So I can afford it. Just kidding. I'm working at IITS Consulting. It's a startup founded in 2019. And like Andy already said, we are both CNCF certified Kubestronaut, and I'm co-published author of the book Implementing GitOps with Kubernetes. If you're starting to building a platform IDP or however you call it, in the most cases you will get in touch with GitOps, and we're also using some topologies from the book here and also covering a lot of other topologies in the book. Ralf Eisenbank gave a talk yesterday, so also showing some GitOps topologies. So yeah, enough about me. We have a lot on the plate. Our target will be first to understand why internal developer platforms and platform engineering matter, and also how we are going from layers to planes, how you can provide a platform at scale, also deep dive into some planes. I guess in matter of time it will be just one plane, and also we're showing you a solution that already built it based on planes, Choreo or OpenChoreo by WSO2, and then we will giving you a short demo so you can see how it looks like or how it feels, and also giving you a recap and also a short learning. But before we are starting, we like to giving you some terms so we have a common understanding for this talk, and Max, will you giving a short introduction?
Yes, so first of all, that's terminology for this talk now, so we don't want to start any discussions on what an IDP is. For us, the internal developer platform is a place where a developer can access the platform, and it doesn't need to be a UI, it also can be CLI or it can be a Git repository as an interface. Second, we have platform engineering, which is everything from DevOps to site reliability engineering, all in one. And the most important thing, it's not only a role, it's also a mindset. So you need to have the mindset for that. And third one, we have the planes. A plane is just a grouping, so you can imagine a control plane where you could, for example, order stuff via an API, which then is deployed on a data plane consisting of workload clusters. Then we have the agentless versus the agent-full approach, which means either deploying the agentless approach with having a control plane and an agent running in there that manages all the workload clusters without another agent in the workload cluster. And agent full would be having different agents in your workload clusters that pull configuration from somewhere. Important to note, if we talk about add-ons, we're probably talking about Helm charts today. And then we still have the push and the pull-based approach. Push-based approach for us is like CI/CD, so a pipeline deploys something somewhere. And GitOps is an agent pulling configuration and deploying it in the cluster it's running. And we know GitOps is way more than that, but for today, that's all.
Thanks for clearing the terms for our session today. We are jumping directly to the numbers. Why IDP matters? It's not our opinion. Just let's take a look on the numbers. If you can see, I mean, Kubernetes becomes the standard for containerization since 2014. Hopefully, we agree on that, I guess. And if you're looking, for example, from the number from Gartner, they say by 2027, it's a report from last year, 90% of the G2000 companies will use container management. They don't say they will use Kubernetes, they say they will use container management. And in 2023, the adoption was below 20%. If you're looking on the report from this year from Google, you can see 55% already using platform engineering by not understanding what it is, but 90% plan to extend it, and we both also are ambassador for platformengineering.org, so we have similar numbers from the research. The most company will go in the next year for platform engineering. So, but first, congrats to the companies, they start or will adopt the Kubernetes part or the container part. But if you're looking at the market, also if you zoom out a little bit, you can see what's happening on the market. So you can see that we have an automatization progression. We are going away from infrastructure as code and configuration as code to package-based, and if it's possible, depending on the customer, on the cloud provider, we try to build everything operator-driven, leverage the Kubernetes API, using the Kubernetes resource model, and to provide not just only the resource, but also the life cycle. And we also go away from the CD push-based approach, especially in the most projects of mine, I guess, in your tool, and to the pull-based. And also in the market, you can see a lot of IDP already are created or are frameworks, and we just put few of them, like, for example, Kubrix. I don't know if you know Kubrix. Kubrix is the IDP out of the box, coming from Austria. And you have something like OpenChoreo we will present. It's built on planes. And we have something like Humanetic. It's an orchestrator-driven part with OpenUI. Port is not an IDP, it's a portal. You need to integrate it. You have Critics, they call it now everything as a service framework, so you can build your IDP on top of it. Or you have Backstage. It's just a framework to build your portal and integrate it. And you can see a lot on the market happening. And now the company is starting, and they will, for example, hire platform engineers or buy a solution and need to integrate it. Or if you're looking at the numbers, this is the direction they want to go. And if you want to hire engineers or platform engineers, they are just numbers from the market. You can see in the USA, a platform engineer earning 33% more comparing to DevOps engineer. In the European market, they're 18%. This is coming from platformengineering.org, and the platform engineering on the right side coming from Code Cloud, and it's coming from Glassdoor. I guess they are the average salaries from the USA. And if you want to understand the difference between platform engineer and managed infrastructure, we are not explaining it today, but we have a blog about it. You can scan the QR code on the left and check it out to understand why the platform engineer is earning more money than cloud engineer, DevOps engineer, whatever. So yeah, and just to the numbers, now we have the numbers. And in the most cases, if we build something, we are thinking in layers. And Max will give you a short introduction on what we mean by layers.
Yeah, so traditionally we have different layers depending on each other. We explained it like with a burger in here. So you have the hardware layer with storage, networking, then you have a hypervisor, or you can also run bare metal. You have an operating system, you have a container runtime, you have the basic Kubernetes, the white Kubernetes services like kubelet, and also the applications on top of it. And that's nice and all, but they all depend on each other, and we need to have a new approach and look at it in planes and not layers, because we can't just start with tomatoes, and that's where Artem will continue.
So I guess you understand it. If you build something on layer on top, you have a dependency, but if you build a platform, you don't have dependencies. You have different planes, and this is a view of also coming from platforming.org. You can build your own reference architecture, maybe you have already, and they think in 5 planes. But before we're coming to the planes, I mean, if I'm using this one and I'm going to Max and ask Max, can you just build it? I mean, I'm giving you everything you need, just build it. Max answer will be something like, I guess,
what should I build?
Yeah, well, what should you build? And if I'm saying, I mean, Max, you are a platform engineer, you saw the salary, so just build it. I mean, I provide you a reference architecture, you have also the errors, just build this. I mean, you're earning the money of, 6 figures, so build it.
Yeah, but wait, what should I build?
Yeah, this is, and then I get maybe angry and say, Max, come on, just build this one. I provide you also the tools, all the icons, you can easy build it. And I guess Max will then getting lost. And the internet had a lot of, wait, what memes? So we are stopping here now. And getting to why it's so difficult to understand, to build a platform, to choosing the right solution. Max, why it's so difficult to understand, by the way?
Maybe just skip to the next slide and the people will understand.
Yeah.
So maybe you already saw this one, like the CNCF landscape. If you haven't seen it before, now you know it. So the platform tooling landscape is similar to the CNCF landscape. So there is multiple tools for the same purpose, and you need to choose from them. So you can't just go to your team and tell them, build a platform tooling landscape, as you can do it with the CNCF landscape. You need to choose wisely what parts of it you want to use, which parts fit your use case and also fit together. So that's why it's hard to just build a platform with the platform tooling landscape.
And if you don't saw the landscape yet, so now you have it. Our mission is to going to every conference and making sure that you see the landscape, just kidding. Getting back to the planes, or seeing how platform engineering see if you build a platform, which planes do you need? You will have a developer plane. So of course, if you're looking at the tools, you will having an access from the developers. They're using IDE, they're using maybe a portal, CLI, API to consume the managed services or everything you provided. They also, if you, for example, provide Terraform models, so they can provision it depending on the customer, depending on the automatization grade, and also depending on the skills of the developer. You have different maturity, how you can provide, but this is the developer plane. And if you are going to the next one, I guess it will be familiar for the most of you. The integration delivery plane, at the end of the day, we will have a CI pipeline, building, for example, also images for us. If you provide something, push it to an image registry. In some cases, maybe you're already using a platform orchestrator or have buy one. Or in the most cases for us is the platform orchestrator and the CD part is combined because we're using Flux or Argo CD to fulfill also the orchestration part, to deploy, for example, a managed Kubernetes cluster if it's allowed with cluster API, to provision it, to deploy another stuff. This is the integration and delivery plane. And then you also have the monitoring and logging plane. I guess you will also be familiar. You can use it for example, combine multiple tools like Dynatrace, or if you're allowed to using a SaaS solution, or now they have also an enterprise solution, if I get it right. Or you can also try to use different solution because we have different customers. We try to combine it and see which solution fits best for the customer. And then sometimes is Grafana Labs or Grafana Cloud, and sometimes is another solution. And if you are attending yesterday to the talk over hotel introduction, you can see the most observability provider trying to provide you now an endpoint, so you can be vendor independent and can just put it to an endpoint. And we are already using at this plane for the logging part, because if you have multiple clusters, you want to push from all the clusters to one endpoint and not deploy the whole stack on every cluster. And then we have the security plane. If you're looking at the security plane, most of you will think, I guess, about secrets management, how you can manage secrets across the cluster, and also how you can manage policies across the clusters. And also, I guess, some of you will using like key clock or identity tools, how you can identify it or getting access through one identity provider to another part. This is the security plane. And now we're coming also to the resource plane, where you can see, for example, having one resource plane or multiple resource plane. For example, one cloud provider can be one resource plane, and you can consume the resources like manage Kubernetes, manage database, everything you need. And if you combine all the 5 planes, you will having a platform in point of view of platformengineering.org, because they try to cover everything you need to provide a self-service. How you build it, it depends on you. And yeah. Why we should think in terms of plans. I guess this is the question you asked me today.
Yeah.
And I say, yeah, if you're trying to think in planes, it's we are not saying you should think in planes. We are saying if you're thinking in planes, you can scale easier, especially for, let's just take a look. We have, for example, here the control plane. Maybe you're already having a similar approach where you have running Argo CD instance or Backstage for a self-service or another solution. So you can provide services to another clusters. We are not saying that every plane should run on a Kubernetes cluster. It's just easier to showing you what we mean by that. And then you can also having a cluster for the security plane, where you manage the secrets, the policies, the public key infrastructure, also observability plane. In the most cases, I guess we are already using, if you have multiple cluster, more than 5, you will using something like agent-based approach and using an observability plane. Let's say Dynatrace, it's your observability plane. So you install the agents, they are pushing the logs, metrics to it. Of course, you can also use -0. I don't know if Dynatrace or -0 running on Kubernetes. It's just to showing you that you can push to it. Also Grafana Cloud, and similar to the identity plane, the most companies we are working with, they're using just one instance, for example, Keycloak running HR, so you can identify it, getting access you need based on the group, and also a lot of companies using DEX as a central unit, so you can identify a DEX, you can federate it to your Argo instances and getting access about it. And we see also a lot of cloud provider starting to building a service plane or a management cluster, they called it, or service cluster. So for example, you can just, if you're going to a cloud provider, you're clicking, I want a database. Behind the scenes, they trigger an event and they will spin up on another cluster, your database, so you can use it. And we have 2 another planes, FinOps plane and environment plane. Over the FinOps plane, if you're in the cloud, it may be interesting for you, especially if you enable your project or product owner. They are responsible for the budget, so they are not running out of budget in May and having free time until the end of the year, until Christmas. Or also the environment plane. But after AI hits the market, I don't see many talks about environment. I have the feeling nobody cares about it anymore. And if you're looking also on the contributions, they are low. The only one IDP I saw in the 3 years having integrated some environment parts, Kepler, it's Kubrick's. But this is what we are meaning and thinking in planes. Organize is a little bit different. And let's getting a deep dive. It's a control plane. If you want, for example, provide a platform at scale. This is a hub and spoke approach. Maybe if you're attending to the talk yesterday, Raiffeisenbank say it's not working out for us. They're using the dedicated cluster per instance or the dedicated Argo CD instance per cluster. And by the hub and spoke approach, you can see this is how the most customers starting to work with if they have the central Argo instance and they deploy the whole stack on every cluster. So you can use it with application set, cluster generator, and labels. You're putting one label on one cluster, on 10 cluster, or 10 or 100 cluster, and it will deploy the same tool on every cluster. You can manage it. This is how you can design it. You can also use Sveltos with cluster profiles, but the problem of this approach is, if you're especially running on edge, you can't just deploy the whole Kube Prometheus community Helmchart on every cluster. So let's say you have your infrastack is consistent of 10 apps infrastack, and you deploy it on every cluster. So after you have 100 workload cluster, maybe you say, I know I saw 100 workload cluster, I have now a project, I have 15,000 cluster I need to manage on edge, and every year 500 coming. So we are speaking at real scale. And if you're having 100 cluster, you need to manage 1,000 application. If you have 500 clusters, 5,000 application. And this is where Argo breaks. We have, for example, these are the benchmarks from CodeFresh. They have done it, I guess, 2 years ago on Google in a HR setup, and you can see, of course, Argo is involved, but you can see you have some applications.
Also, it's important to mention that this isn't without any tweaking, no hydration and so on, so you can scale far beyond also with Argo CD and hub and spoke, but it gets quite complex and a bit dangerous. If you do the wrong thing, you can break your system quite fast. So that's why it's hard to scale.
Yeah, it's true. And you can see you have some limitation, and one application, it not meaning it's the same every time. You can using one application with 3 objects. If you're deploying with Argo CD, for example, the Kubernetes stack, it's having more objects inside. So one application is not defined. And you have also managing some clusters. So this is where if you're starting to working at scale with the hub and spoke approach, you're getting in problems if you're not thinking in part of planes. And how you can, for example, avoid it. And Max already gave you the short introduction to the terms, what we are meaning by agentless. And if you can see a lot of tools supporting like Argo CD, so you can having a control plane, and you can run, for example, external secrets operator on it. You don't need to deploy it on every cluster to manage the secret. You can manage it centrally on every cluster by keeping, of course, multi-tenancy, also providing some security, but then you can reduce the count of the dedicated instances on the cluster itself. Of course, you can also using different topologies, but we are here to showing you that if you're, for example, using planes and can move your tools to the control plane, you can manage it easier. But not every tool supports the agentless approach. So if you are thinking in ops part, in the most cases, you will deploy agents. And agent means you have we call it just observability agent. You deploy the observability agent at the workload cluster, for example, and it will push logs, metrics to one destination or to different destination, how you define it. And similar you can do with, for example, Sveltos to managing add-ons. They have a pull and push-based approach, and you can see you need to see how many tools you have, or which tool supporting the agentless approach, which tool supports the agents part, and you can also combine it. But the target should be to try to move a little bit the tools to the control planes. If you want to build a platform that scale, especially if you have edge requirement. And yeah, you can also mix both approaches. You can mix agentless and agents. And Max will giving you, for example, a deep dive in how you solve for a customer already the observability part, and you can take a look at the observability plane, how they solved it. So you're getting just an idea how you can also solve it with different solutions.
Yeah, so that's a setup we already deployed at multiple customers, and it's using only open source tools in air-gapped environments. So we have a tenant cluster, which can be 1 or 100, so it's scaling quite well, where we gather all the metrics, logs, and traces. You can see it at number 1. And there is like a local distribution layer, like hotel collector to aggregate all the data and maybe also filter it to make sure data that's not allowed to leave the cluster because of data privacy or similar stuff is not leaving the cluster. And then we send it from there to our central observability cluster. You can see it at number 2. We authenticate the traffic with MTLS between those clusters. And then we have our central distribution layer, which is again OpenTelemetry collectors to be able to filter here again and maybe replicate to a SaaS solution or to another observability solution. And then we store it in our backend stores where we're using Thanos, Loki, and Tempo, which all reside in an S3 store. So that's the way how we get the data in our backend, and now we have a look into how to query it again. And that's where number 3 comes in. We have a Grafana instance somewhere. It doesn't need to be a different cluster, so it could also run in the observability cluster. It's just separated in the drawing, so you know it doesn't need to be there. This Grafana instance has a special configuration called forward OAuth header in the data source, which forwards the OAuth identity header of the user currently using Grafana to our custom label proxy, which you can see on number 4. That's a little tool we at Evola are currently building, and we will open source it probably end of the year. And this tool just understands PromQL, LogQL, and the tempo query language, and adapts it so that the queries only give results the user is allowed to see. So the user has some groups or a username, which then is mapped against rules. So the proxy adds where clauses to the queries and only gives back the data the user is allowed to see. The benefit of this is that you can have one dashboard for your whole company, and everybody's only seeing what is allowed to see and what's important for this group of people.
Like already the most SaaS solution providing you try to rebuild it self-hosted because you are the most customer on premises and air-gapped and things like this. You may be thinking, I mean, we want to share really much information with you, but we can't go deep dive on every plane, so you can see it how it works on the observability plane, and maybe you're thinking, sounds like a miracle, who built it in planes? We can say not at all, because Choreo and OpenChoreo by WSO2, don't know if you heard about it, built it this way, and WSO2 is a company from Sri Lanka. They have now 20 years of experience in building API management, platforms at scale. They have trusted customers like BNY Mellon, which manage 50 trillions in assets with T, and also they're building an IDP with this API-driven mindset called Choreo as a SaaS solution. And for me, it was like I was last year attending to the KubeCon NA. I have in mind how I want to build an IDP and a platform, and looking at the solution, for me it was like they built it, but in a better way, and for me it was like, wow. And then I told Max this year, Max, please go there and tell me what you think about it. And Max's expression was, I guess...
Yeah, I also liked it very much. It was a nice approach, so that's why we choose to disassemble this one.
We want to share with you, but we are not focusing on the Choreo part. They also released this year the OpenChoreo. It's still not production ready, but it will at the end of the year. But we want to show you how they build and think in planes, so you're getting a new point of view, because I guess you don't saw a solution like this one. And if you're looking at OpenChoreo, you can see they also choosing the planes approach. You have the control plane running the controller manager, API server, then they have the data plane running the workload, and they just deploying the necessary resources they needed. They have the Envoy gateway, they have also Fluent Bit, they have a Vault, they have a registry. You will understand in a few slides why they're using it like this one. And they also have an external and internal way to expose the traffic. And yeah, they also have a build plane. The build plane builds the artifacts. It's also a big pain point for the most developer. We will also see how they solved it. And they have an observability plane also. And at the moment, they also integrated the identity system. So you are not just having the network policies and also MTLS enforced, but also if one service A want to speak to service B, it's needed to getting a short-living token so they can authenticate against the service. This is what I mean. They built it the API-driven way, and we really like it because every plane is provided as Helm chart, and you can just integrate it in your platform, or if you start to build it, maybe you should take a look, getting inspired, use it, because they're also covering the developer control plane really well. We also will showing you at the demo, and this is how they built it. And what happening after they spin up the data plane or data planes, they will register at the control plane, also the build plane. After that, what happening behind the scenes, the data plane and build plane will connect it to the observability plane, pushing on a multi-tenancy cell-based approach. Max will give you in a few minutes what it means, cell-based approach, pushing the data like in a domain, and the developer just seeing based on the organization and project how they need it. And of course you have a connection to Backstage, remove some errors here, so you're just getting the ID how they built it. And yeah, why this matter? Because as a point we are now impersonate the point of the developer control plane. you can see the developer can, for example, they just need to go into Backstage. Of course, they can also using custom resources. They just need to provide a repository and creating a component and just choosing, provided by the platform team, and project and organization. And behind the scene will happening something like the developer don't see the build pipeline. The developer say, for example, I want to using the continuous integration built-in part because I don't know how to build a container. It will cover it from Choreo. It will using build kits, detect the framework, build the container image, push it to the dedicated data plane to the registry. So it's lying every time on the data plane, and then the developer doesn't need to know where his workload running on it because the platform team's already making the connection between the organization, between also the data planes based on the project, and the developer just need to say, I want to expose it in my organization, between the organization, or externally, and they will cover everything for you at this point with network policies, MTLS, and so on. And
so I'll jump in here. So as Artem already mentioned, the nice thing is that the developer doesn't have to care about all this infrastructure and platform stuff. He only has to code and push his code, and everything else is handled by the pipelines and definitions of the platform engineer. And if we skip to the next slide, we can also see the cell-based approach. So all the way down where the platform engineer is, you can see like around the project there is different ingress, egress, and internet connections. So we have a cell that's always a project, and it's secure by design because you would have to define what ingress or egress you need, and if your application is published internal or external. Yeah, that's another view on what exactly the platform engineer has to define. The platform engineer defines an organization and project and the environments for this project, and also the platform engineer defines which deployment pipeline is deploying the different stages and to which data planes. So the developer will not know and doesn't have to take care about where the application is running.
Yeah, this is also a really nice approach because behind the scene you can using, like Choreo using for the SaaS solution already Keda, to having as the best utilization of the data planes, and they also scale down, scale up the workflow. You can enable it, and you can also use Carpenter, for example, to getting the best images or the best VMs you have. And I don't know if you heard about Q, now machine learning, GPU coming in. You can also schedule the workload on the empty cluster, because if you are looking at my customer, if we have 20 clusters, I have a utilization on some clusters by 80-90%, and at some cluster 10-20%. So you can also use it to combine it. And also we see the benefits of OpenChoreo.
Yeah, the benefits are that you can scale quite easily because of the plane design. It's nice that you can treat your clusters as a herd. So maybe you already heard like the saying, you shouldn't treat your clusters and nodes as pets. They are cattle, so they should be replaceable and ephemeral. You can optimize utilization. The thing is secure by default because you have the cell-based approach. So your application is always, or your project is always contained. You have a single pane of glass. It's focused on developer experience. So your developer only has to write code, and he doesn't have to take care about some Docker file or manifests or whatever. And it's also easy to use in big organizations because of the domain-driven organizations plus projects approach. And it's quite easy to integrate GitOps as it's all Helm charts.
Yeah, it's true. Let's taking a look at the demo on Burn the Ships, so you're getting a better overview how it works behind the scene and why we found it so beautiful how they built it. It's not just about putting or creating the build artifact for the image. It's also, for example, putting it to the right manifest just by developer. Just need to say, for example, I want having an API, I want to having a web application, and so on. This is get me something so like this one. This is a demo environment. I need to look at this screen. Hopefully it works out. We're using the single cluster approach. We don't spread it over, distributed it. It's a single cluster approach. You have the data planes based on the namespaces. And also you can see here, we have all the data planes running in the namespaces with all the components we needed. And if we are taking a look and impersonate, for example, going to the backstage part, you can see here, for example, after you integrate your IDC provider, you can create your organization, you can create also your projects. If you are going there, you can see we have in one organization, we have 2 projects, and the one project is part of the default organization, maybe not the best names. And we have also deployed some APIs already there, and we also have a web service running on it. And they also integrated the cell diagram with the...
So that's the cell-based approach I was talking before, and you can even see like the ingress and egress rules, and if they are internal or external in this diagram, which is really nice integrated.
And if you're going, for example, to my groups, let's go into the web application. Yeah, I need to take a better look on it. And if you can see the developer create a component, say it's a web application, then the developer can, for example, provide and say it should be built or using the CI instance, then it will build for it, deploying to the data plane defined by the platform team. And after that, it will deploy it. Also, we are using 3 stages here, the development, staging, and production. And it will automatically deploy it to the development. You can create quality gate between the stages, so you can also enforce your compliance needed between the different stages. And point on the developer, you just can say, for example, here promote, and it will just promote it. You can suspend it, and in the backend, everything is managed by the controller. So everything are custom resources. You can also, of course, doing it the hard way, and also create the custom resources from components, workloads, services, and so on. And you can also, if you're going here, for example, you can see if you're going, this is that the observability plane is also connected to the backstage part. So you can see, I mean, it's just a React application. You can see the logs here as a developer. You're having just one point you need to go, and you need just to focus on the code, and it will be handled behind the scenes. And this the approach we really like. And for example, if you want to create a new component, this is how it looks like. They scaffolding it, created some template. You're going to the component, you can give it a name. This is not spectacular, but this one, you can choosing the project, you can choosing the organization, and the type. You can define your own classes, because the most developer we see struggling with not just building. I was last year I was involved in 2 pre-security audits. After the pre-security audits, we can say shut down please the whole environment, because we're finding a lot of security issues. And yeah, it was also in critical infrastructure provider area. And because the developer don't know how to build first the container, yes, of course you can educate it. And they also, I mean, for the most people saying, yeah, a web application is simple. It's not. You need to understand security context. You need to understand if you want to configure HBA, that you have a matrix server running on it. You need to understand a lot as a developer, and the most developer don't want it. And you can provide the classes they're choosing here. And for example, it's a web application. Everything will handle behind the scene also. And they are not just only developer driven how they build it, they're also having that as API driven mindset. Hopefully you're getting a short overview how they built it, because we wanted to reverse it, and this is the backstage portal, and you saw the planes how they built it. You of course you don't see the controller. To see in the controller and understand it, you need to look into the Go code, but you can combine everything. We removed the GitOps approach at this part, but at the end of the day, to put GitOps on it, it's not the magical one to putting the Helm charts into a catalog. And I guess we are running out of time. We wanted to share more parts with you, but maybe in another session. And so let's going back to a short recap. Now I need, yeah.
Yeah, so we are sure that internal developer platforms and platform engineering is here to stay. So this will be important in the next years too. We will need to rethink our platforms, because simply scaling the current setups won't work. It won't be enough in most cases. Platform engineering can be quite expensive, so there's also the cost topic, because a platform engineering team can easily cost 1 million per year. So the platform itself must scale to justify the investment, and also your business needs to scale, because it's not useful to build a platform just for the platform's sake. You should also have a use case for it. And we also think thinking in planes is the correct approach for us to scale better. And we can see that the observability, because observability already works that way, and we think applying this concept to other topics will create easier scalable platforms.
Especially if you have requirements like managing 15,000 cluster. Science 2 weeks, I don't sleep very well after I get it. But yeah, you need to redefine and to think. And also, Max mentioned a real goal. A lot of companies starting to build platform engineering teams, spending a lot of money. It's cost you not just 1 million per year, it's cost you about 2 and 3 years. This is our experience. And you spend about 2 and 4 millions because you want to go 24/7. And I had a customer, I was looking at the business, I say, your business doesn't scale. Why you want to build a platform team? Because you have also a separate infrastructure until you migrate it. And I say, please focus first on the business. After the business scale, you can think about building a platform team. Also a lot of customer losing the point to focus again on the business and building what matter for them. So we are not saying here, platform engineering is the right way and you should build it. It's depending what are you doing. If you have, I don't know, maybe if you have working with 20 developers and you have 3 or 4 platform DevOps engineers, however you call it, it works out for you. If you have 4,000 developers and 10 or 15 platform engineers, maybe you should think to build a self-service, but it takes time. And I also gave a lot of talks about why companies still failing building an IDP, and it's not easy. And yeah, I guess we're running out of time.
So we would really love to hear what's your opinion on the planes approach. And so we're coming to the Q&A, and I will be available like today and also at the Cloud Native Vienna meetup in November. It's 10 years of CNCF. You can get the meetup link at the QR code. And also Artem.
I will be at the KubeCon NA if you want to chat, to grab up signing book. We will giving a book signing and giveaway, books for free, signed with some champagne, I guess, like this year. And yeah, just visit the vCluster booth. And also if you have some question or want to discuss it or discuss this new approach, how they built it, because we as engineer love to seeing many things, so we can put everything we needed together and build it for the customers the best way they need it. This is our approach, so we are every time curious, just drop me a LinkedIn message, or Max provided you multiple more resources with link stack. You can also drop him a LinkedIn message if you have questions to home lab, to his home lab. And thank you very much that you're attending. And also, I know it's a lot of information and a lot of different information, but we try to giving you this new view, and we will really appreciate it if you can provide us a feedback if you like it, if it's what's too technical, not technical enough, what you wish. And so we will also
like the middle QR code is for feedback.
Thank you very much.
Thank you.
Thank you, Artem. Thank you, Max. I think we had a couple of platform engineering talks over the last 2 days. It's always great to get different opinions and different expertise and backgrounds. So also thanks for giving us the QR codes to provide feedback and also connect with you, because we are all still trying to figure all this out. I'm just curious though, because the term platform engineering, the topic has been around, it seems, on the conference circus now for the last 3-4 years. How much longer will we talk about platform engineering until there's another thing we need to solve?
If we are looking at the numbers we are getting from research until 2027, it's sure. After that, I don't know. I guess it's will happening like DevOps. We will get a little bit tired of DevOps, so we need a new term. Nobody can explain. They want to say it's tool, it's about collaboration, it's a mindset. Hopefully it's not happening to platform engineering. This is also our mission with platformengineering.org. But at the moment, it's drifted a little bit away because the relabeling happening faster. If you are going to LinkedIn searching for the profile for platform engineering, you will see that the people doing the same things just relabel it. And yeah, because it's fancy to having a title like a platform engineer.
Gives us more ideas to write books. Here we go. Questions. We have 3 minutes time for questions before we get ready for the final keynote. There's a question here.
Thank you for the talk. Really interesting. I asked the same question like two weeks ago at another conference about platform engineering. Was another keynote, and I asked like if you can summarize it just in one sentence. Like you personally, what is platform engineering? What would it be?
In one sentence? I can give you in 2 or 3, or try it. I make a difference between, for example, I say what I'm doing for some customers, managed infrastructure. Managed infrastructure is a new project come in, for example, I getting a ticket request, whatever, I providing the infrastructure, all the tools, and enable the developer to use it. This is for me managed infrastructure. And if I'm doing platform engineering, I'm providing like GCP, a platform, try to build it so the developer going to one place can consume what they needed for the enterprise to fulfill their task, but the ownership change. So in my point of view, by managed infrastructure, I build the Terraform models for mine, so I know how to use it. But then you are building something, the developer can use it. And after they spin it, of course, you need to build it. So people say using golden paths, using self-service. It's not so easy how it sounds like. Because of that, you're getting a high salary, because you need having a software engineering background to build things like this. And at the end of the day, the ownership change. So it's also a mind shift. If you're working with companies or customers, they having IT over 20 years, it's a little bit difficult because they can't giving away the ownerships to the developer. So you also need to giving the mindset, giving time for the mind shift to move the ownership of it. So yeah, it's more than 2 or 3 sentences. It's a difficult topic, but we can discuss it after talk if you like.
I'd say like a biggest thing is self-service and enabling developers and abstracting the complexity of infrastructure away of a developer.
Introduce the cognitive workload. This is how we promote platform engineering.
All right, any other questions? We got another question slot open. No? Okay, in this case, Artem, Max, thank you so much again.
Thank you.
Another round of applause.